This is the beginning of chapter 9, where we are going to be studying how to solve different systems of equations. So in this section, 9.1, linear and nonlinear systems of equations, we're going to start off by exploring one of the two methods that you probably are already kind of familiar with. We have the substitution method, and then we also have the elimination method, which is sometimes called linear combination, that you're probably familiar with. So this lesson is going to be talking about the substitution method. And so there is a step-by-step process to that. You're used to using this for linear systems. We've actually used it for other systems. We just got done in the last chapter when we were dealing with exponential functions. We had a problem where we were given 2 points and we had to find the equation of the exponential function. And we're given 2 points. We plugged in both points. It actually gave us two equations. One was very simple, where we were able to find A immediately. And we substitute that value into the other equation to figure out what B was, and then we wrote the equation. So technically, that was the substitution method. So we use it for other systems, not just for linear systems, but like I said, that's the one you're used to. So the substitution method, the first step is to solve one of the equations for one variable in terms of the other. So if you have a system with x and y in it, you're going to either solve the first or second equation. You have to have two equations, typically, if you have two variables, three equations if you have three variables in your system, and so forth. And so you're going to, if you have x and y, you would take either your first or your second equation, and you would solve it either for x or for y. Typically, what you do is you pick the one that's easiest to solve for. So if you see a x that's just a 1x, it's going to be real easy to get that by itself. Whereas if you had like 5x, and you go to solve for x, you're going to have to divide by 5 to get the x by itself, which means you're going to end up probably with some fractions that you're in an expression that you're going to substitute into something else. So we really don't want to do that. So we want to do this, but we want to strategically do it to make our life as simple as possible. So you're going to pick one of the equations. You're going to solve it for either x or y, typically, if those are your variables, and whichever one is simplest. Then you have to get both equations involved in this process. So what you do is you then substitute that expression you found in the first step. So if you solve the first equation for x equals, it's going to have something with y in it. You're going to substitute that expression that has y in it in for x in the second equation. So that's what this is saying. Substitute the expression you found in step 1 into the other equation. A common mistake, the students will substitute it back into itself. And that doesn't work. It's not going to help at all. You've got to get both equations involved. Once you do that, if you have two equations, two variables, you now are going to have a new equation that only has one variable in it. And that, in that case, what I was describing, it would only have y in it. And so you will take that equation that only has one variable in it, and you'll solve it using the methods that you already know. So if it's a linear equation, you'll use the methods you use for solving a linear equation. You'll undo what's added or subtracted from your variable, then divide by what's multiplied or divided by your variable, and you'll have that variable by itself. If it's a quadratic, well, then you'll use quadratic techniques. And so typically with quadratics, we get it equal to 0, and you solve by factoring or the quadratic formula. So remember, these are not necessarily linear systems. We might have a nonlinear system. It might have something quadratic in it. So we're going to use whatever technique it takes to solve that resulting equation. Then you'll substitute that back into this expression that where we originally solved for x, and we have x equals with something with y. Once you find y, you can substitute y back in there, and you can figure out what x is. That's what that part is. So this is all stuff you've done before, but we're just going to be applying it to linear and nonlinear systems. Then you're going to have an x and a y, so you need to write your answer as a point. So it's an ordered pair that makes that equation true, because we're talking about, if it's linear, you're talking about a line and another line, and where they cross is at a point. Or even if it's a parabola and a line, then you might have a couple of points where they cross each other. You need to write your solutions as points, and then you need to check them in the original equation. So you plug it back into the first equation, make sure that point makes that true. Plug it into the second equation, make sure it makes that one true as well, because it may make one true and not the other. So it's got to make both of them true. Okay, so now I'm going to show you some examples of that. So here I have a system 4x minus y equals 1, and 6x plus y equals negative 6. If you think you have a handle on solving using the substitution method, my suggestion is pause the video, go through and solve this yourself, and then check to see if you do it the same way that I do. So, I'm going to assume that you've already done that, and when I look at this, I'm looking to solve for one of the variables. It doesn't really matter, but I wouldn't solve for x. I wouldn't solve for x in either one of these because I'm going to end up having to divide by a 4 or a 6 if I do that. Again, it doesn't really matter which one you do. If I solve for this one, it's a positive 1y, then all I have to do is move the 6 to the other side. So the first step is to get y by itself. So y equals, if I move the 6x to the other side, negative 6x minus 6. So that's step 1. And then I'm going to substitute that expression in for y. So in the other equations, it's going to go right here. So that's step 2. Now be careful, because there's a negative in front of that y. This is where a mistake gets commonly made. It's a minus, and then you're substituting this in right here. So this is where the negative 6x minus 6 goes, but there's a negative out front. So I would want to get rid of these parentheses, distribute the negative, and so I'd have 4x plus 6x plus 6 equals 1. And so this is what I was talking about before. Step 1, you get the variable by itself. Step 2, you substitute. Once you do that, you get an equation that only has one variable in it. It's a linear equation because x is only to the first power. So I'm going to solve this the way I normally would solve a linear equation. I'm going to combine these together and get 10x plus 6 equals 1. Subtract 6 from both sides. 10x is equal to negative 5 when I subtract 6 from both sides. And then divide by 10, and I get x equals negative 1/2. Then that's half my solution. So far, my answer is negative 1/2 comma something. So you take this expression and you substitute it, this value, substitute it back here in step 1. So now it becomes negative 6 times a negative 1/2 minus 6. So that's going to be a positive 3 minus 6, or negative 3. That is my y value. And so then I would substitute that back in here. I would take, you could use your calculator for this, 4 times a negative 1/2, which would be a negative 2, minus a negative 3, which would be like a negative 2 plus 3, does equal 1. And then I'd substitute it in this one. 6 times negative 1/2, that's a negative 3, plus negative 3 does equal negative 6. So it checks into both of those, so that way I know that that's my answer. A common mistake for students, again, is to not check their answers. And they just go, well, I hope I got it right. Well, there's no reason for these, for you to get them wrong if you still have time to work on it. If you're taking a test and you run out of time, that's one thing. But if you are taking a test, and what I suggest is you go through and do like all the problems on the test, make sure that you've completed the test first, or done all the problems, and I realize that's hard to do sometimes with Google Forms. But at least all the problems from that section, if I have some of these in a section together, and go through and make sure you have them done. Then go back and plug these numbers back in to see if they work. And if they don't, then you know that you need to go back and try to figure out where your mistake was. Okay, so here's another one. Again, both of these are linear. X and y to the first power, x and y to the first power. So it's another linear system. So I would suggest you pause the video, do this on your own, and then watch me do the problem. Or you can even, again, I think that there's some good information in here that I give you. So I don't know that you want to be necessarily fast forwarding just to the answer, because I might have little hints that help you, okay? So try to keep that in mind, especially when we get to the elimination method, but that's the next type of problem that we're going to do. So in this one, again, you can solve either equation, but I would take this one and solve for y. Y is equal to x. And then I can substitute this in for y in the other equation, and I would get 2x plus x equals 6. 3x is equal to 6, so x is equal to 2. So there's half my answer. Go back here, plug it back in here, not a whole lot to do. Y equals 2, so that's also 2. So plug it back in. All right, so 2 times 2 plus 2 does equal 6. The opposite of 2 plus 2 does equal 0, so it does work in that one as well. Okay, so I don't want to spend too much time on that. If you are confused on something, you can ask me during our Google Meet Live. Now, this is where we get into ones that are not linear. This is a linear equation, x minus y equals -4. This one, though, has an x squared in it. But the process is still the same. I'm still going to take one of these equations and solve for a variable. So I would solve this one, let's say, for x. X equals, if I move y to the other side, y minus 4. And I'm going to substitute that expression in for x right there. So this is going to become y minus 4 squared minus y equals -2. So when I square this, I get y squared minus 8y plus 16 minus y equals -2. So be careful here. This is a binomial squared. That becomes a trinomial. So I now have y squared minus 9y plus 16, but if I move the 2 to the other side, it becomes plus 18 equals 0. So now I want to try to factor this if I can. It's quadratic. So I would prefer to factor it if I can. Y, -6, -3. So I get y equals 6 and y equals 3. So there are going to be two solutions to this problem. I've got one solution that is something 6 and another solution that is something 3. And the reason for that is that this second one is a parabola and this is a line. If you have a parabola and then you have a line, it's possible for it to cross it twice. If it was down here, it might only cross it like, it might be tangent to it, okay? Or it might miss it altogether. So when you have a line and a parabola, you can either have no solutions where the line doesn't cross it, one solution where it just touches it, or two where it crosses it twice. So we want to find both of those. So you go back to this part right here, and you're going to plug 6 in here. 6 minus 4 is 2, so the 2 goes with the 6. Plug 3 in here. 3 minus 4 is -1, so I get -1, 3. And again, you need to check those solutions to make sure that they work. So 2, 6, -1, 3. Okay, so here's another one that you may want to try on your own before I do so. So I'm going to assume that you've already tried this, that you paused the video and then you tried this. So again, it doesn't matter which one you solve, but typically if you have, I've got x squared and x here in the same thing, and you could solve for x, but it's better if you solve for the variable that is only a linear term, y here. I would solve this for y and get, this becomes y equals -x squared. And I would put this in the place of y into that equation. And so that equation becomes x squared minus 4x. And then be careful here, it's the opposite of y. Y is -x squared, so the opposite of y would be a positive x squared equals 0. So this is 2x squared minus 4x equals 0. Now, this is one that definitely confuses students because we spend a lot of time in first year algebra and second year algebra factoring quadratics that are trinomials, where they factor into two binomials. We spend a very little bit of time factoring them when they're not trinomials. We have this thing called a common factor that you're supposed to be looking for, but they don't come up that often. But they start coming up more now, and students overlook that. If there is no constant here, then both of these have an x in them. So you should be able to factor out an x. Not only that, 2 and 4 are both divisible by 2. I can factor out a 2x. So if I take a 2x out of this, I'm left with an x. Minus, take a 2x out of this, I'm left with a 2 equals 0. I have two factors. Set this factor and this factor each equal to 0. You get x equals 0 and you get x equals 2. So I have two solutions that I'm going to have. One is going to have an x value of 0, and the other one is going to have an x value of 2. And then I need to find both of those. So now we go back here where I've got y equals this. Well, I want to know what y goes here. Put 0 in for x. X squared, 0 squared is 0. The opposite of that would still be 0. So I get 0, 0. If I put 2 in here, 2 squared is 4. The opposite of 4 is a negative 4. So that's my second solution. Now, it does say to verify the answers in the original equation and graphically. So I know I haven't done any that are graphically. You could go through and you could graph these. Let's see if I can pull up my graphing calculator for you real quick. So if I'm looking at like a graphing calculator, or you could do this by hand with XY charts, I could go to y equals on my graphing calculator, so hopefully you can see that. And I had this one equation over here that was y equals negative x squared. So the way I would type that in is I would use the negative sign down here that's down by the lower right hand corner. And then I would choose my variable, which is right here by the alpha button on a graphing calculator, x, and then squared. So if I do that, and then I do zoom, you just hit graph, but typically I'll do zoom 6, so it sets up my window properly for me. You'll see that that indeed was a parabola. Now the other equation, if I go to solve it for y is equal, if I move y to the other side, y is going to be equal to x, this x squared minus 4x. So can't really see that because I've already covered that up. But I'm going to go back to y equals, and I'm going to type in the second equation, x squared minus 4x. And hit graph again. And you'll be able to see, I know there's a lot going on here. So I'm going to clear these annotations for a moment. But you can see in this graph, it's crossing in two spots. And it appears that they're crossing at the origin, which is 0, 0. And it appears that they're crossing over here at 2, negative 4. I could look that way. There's also a way to go to the table, which is above the graph button. So second table. The table is kind of showing over here anyway, but I'm making it a little bit bigger for you. You can see that when x is 0, both the first function and the second function have the same y value of 0 here. Okay, hopefully you can see that. I know I'm off camera right now, but when x is 0, they both have the same y value of 0. When x is 2, they both have the same y value of negative 4. So 2, negative 4 is the other solution. I can see that here in my xy chart. So the main reason I'm doing that is, again, you could just create an xy chart if you needed to. You could just do, for y equals negative x squared, you could just simply start plugging in values like negative 2, negative 1, 0, 1, 2, 3, 4, whatever you wanted to make an XY chart, find a bunch of values and plot that point if you need to. Or it is a parabola. You should know its vertex is 0, 0, it opens downward, things like that. Same thing with this other one. You've got y equals x squared minus 4x. You could go through, well, first of all, you could factor that and find out where it crosses the x-axis at 0 and 4, because that's factorable. But then you can find other points, making an XY chart. So there's lots of ways to do it, but I wanted to show you how you could do that with a graphing calculator. So I'm going to pause there, and we'll pick up with the next example in the next video.